Hello everyone, welcome to day 58 of building the flight booking engine. We have learned so many things and today we want to start learning Kafka. Sorry for starting late. I got a little bit of challenges here, but I am now happy to start today's stream. And I hope you're as excited as I am to learn several things concerning Kafka. Like I promised you, this project covers everything. It covers the front end, the back end, DevOps, literally all concepts. Okay. I want to cover almost all concepts that you need to succeed as a software engineer. And also, this is my way of making sure that I build a good application beyond the basics using FastAPI. And now let us start understanding what Kafka is today. Okay, before we implement Kafka into the flight booking engine, we must first of all understand what it is. Okay, so I don't want to rush into the coding and that kind of stuff without letting you know what it is. Okay, so let us understand the what. What is Kafka? Why? How does it work? So by the end of this stream or this video, make sure you understand it. If you don't understand it, please go ahead to ask me questions. For those who are watching live or for those who are watching after the stream, please you can go ahead to leave a comment and we can go ahead and learn together. So first things first, okay? What is Kafka? Okay, so Kafka is simply a distributed event streaming platform. Okay, let me get writing. So it's an a distributed event streaming platform. Okay, distributed. So I want to write those keywords. Okay, and as we go on by the end of this stream, you should understand these keywords. So it is a distributed event streaming platform. Event streaming platform. So these are the two keywords I want you to understand. Okay, distributed and event. And it is used for building real-time data pipelines and streaming applications. And they designed Kafka, the creators of Kafka designed it in such a way that it can handle large volumes of data in a very scalable way and a fault-tolerant manner. Okay, so because it is fault-tolerant and can handle a lot of data, okay, in a scalable way, it is very good for things like real-time analytics, data ingestion, and event-driven architectures, okay? But at the very core, okay, Kafka is actually a distributed publish, subscribe messaging system. If you've been following very diligently, I am sure you're aware about publish, subscribe, because we talked about it when I think between day 50 to 50, maybe 55, when I was talking about server set events, okay? We dealt with the publish, subscribe in Redis. So Kafka is the same thing, okay? But something way much better, okay? So let us get into it by understanding what an event is, what is event streaming, what does it mean for it to be distributed, and so on and so forth. So what is an event, okay? An event is simply anything that has happened in the world, okay? Something or anything which has happened in the world, could mean the world, in your business, okay? That is what an event is. So we're now getting deep into the concepts. What is an event? I'll maybe pick another color for this, okay? Let's go on talk about our events. And like I've said, an event is simply a record of something which has happened in the world or your business. For example, if you were working with maybe a travel app, maybe like Uber, okay, a taxi app, or maybe a ride sharing app, okay, an event would be made up of a number of things, okay. First thing is the key. Okay, an event is made up of a key. An event is made up of a value. Okay. What else makes up an event? Who can guess? The timestamp. Timestamp. So very important that you understand this. So all these three, okay, make up a piece of event data. Okay, they make up a piece of event data because it describes what happened, when it happened, and who was involved. Okay, and that's the purpose of event streaming. Okay, tell us what happened, when it happened, and who was involved. Okay, when that thing happened. Okay, so that's what we are purposeful about. So imagine like maybe in an event streaming platform, okay, that is responsible for constantly giving us important information about maybe rides, okay, that are happening. Okay, so in a ride share system, we can see maybe the key is that we have maybe Alice, okay, Alice, who requested a trip, okay. The value could be requested a trip, requested, if I can type requested well, sorry about my handwriting, requested a trip, okay. Then finally, okay, we can have the timestamp, okay, that this happened maybe on June, okay, June 30th, okay, maybe 2025, okay, at, okay, at 2 p.m. Okay, so depending on what this is an example, okay, on what you're doing, okay. For example, in our example, sorry, my box has not been quite accurate, okay. I'll draw it better to cover all this piece of data. So this is what an event is, okay. A piece of data which tracks what happened, when it happened, and who was involved. So make sure you grasp this. For the case of our flight booking engine, an example would be, okay, maybe Nehemiah, okay, has paid for a flight booking from Italy to Nigeria. And this was booked on the 23rd of December, 2025 at 7:30 a.m., okay, West African time. That is an example of an event, okay. Now, I said it is an event streaming platform. What does that mean? Okay, sometimes we get continuous pieces of data, okay, continuous pieces of input. These continuous pieces of input are called streams, okay. So we can have a continuous input of events, okay, and a continuous output of these same events being processed in a continuous manner, okay, whether immediately or later. That's what streaming is all about. Now, Kafka does not handle these events individually, okay? There's something what is called a topic, okay? A topic. So let me write it down here. Pick different color, okay? Let's talk about topics. What topics are in Kafka? So, Kafka organizes events or streams of events in categories, okay, called topics. So, a topic, okay, is simply a logic organization, okay. For example, in our flight booking engine, we could have this. We could have a topic, okay. Can say, so I want to put here a first topic, okay, called maybe tickets, okay. And this topic called tickets is going to be a logical organization, okay, of events, okay, that are concerned with tickets, okay. Like when a person creates a ticket, when an admin uploads a ticket, okay, that will be one event, okay. Maybe another event, then another event, okay. Then we have another event for a ticket, another ticket upload for another user, another ticket upload for another customer, another ticket upload for another customer, another ticket upload maybe for for the same customer probably, but a different flight, okay. So all these are events, okay. But all these events are grouped, okay, into a common logical container, okay, called a topic tickets, okay. Then we can have another one. We can have another topic here called payments. So this topic called payments will be concerned with all events, okay, for payments, okay. So when a user has paid successfully, we have an event, okay? So an event, okay, an event, and so on and so forth, okay? We can also have another topic called bookings, okay? So this handles events when a user, for example, confirms a booking. So that is how Kafka organizes its things. Now, to move a little bit further to understand certain things, okay? I want to talk about a few characteristics of topics, okay? So a topic is append only, okay? You can only add to the end of a log, okay? You cannot add to the beginning, only to the end, okay? For example, if I wanted to add an event to the payment topic, okay? I would only add it here, okay? At the end here. I cannot add it here, okay? This is forbidden, okay? You only add at the end. This is because events in Kafka are ordered, okay? They are ordered in a specific way and they're processed in that specific order, okay? Another thing you have to know that events in a topic are immutable, okay? Meaning after it has been written, you cannot change it, okay? That's the meaning of immutability. You cannot change it, okay? So understand that, okay? And now to go a little bit deeper, I want to talk about what they call brokers. Let's go down here. Let's talk about brokers, okay? Before we continue, let's talk about brokers. Let me use uppercase just to be consistent. What are brokers in Kafka? Okay. So a broker in Kafka simply refers to a server. Okay. What is a server? A server is simply a special computer. Okay. Having capabilities that can help you to do things that a normal computer cannot do. That is what a broker is. Okay. So a broker is simply a server in Kafka. Okay. Which is in the Kafka storage layer and is responsible for storing event streams, okay, from one source or more sources, okay? So a Kafka cluster is usually comprised, okay, not compromised. English is becoming a bully right now, okay? So a Kafka cluster is comprised of several brokers, okay? And every broker in a cluster is called what they call a bootstrap server. Okay. So what does bootstrap server mean? Bootstrap server means that when you connect to one broker in a cluster, you can connect to every other broker. Okay. So a broker is simply a server. Okay. And whose purpose is simply, okay, a server that stores event streams. Okay. A server that stores event streams. Event streams. Say a server that stores event streams from one or more sources. Okay. So like I was saying, these clusters are also known as bootstrap servers, meaning if I connect to one, okay. So let me draw this. Assuming you had this as a cluster. Remember what a cluster simply means? A collection of things, okay. So we have here one broker. It's a server, another broker machine here, okay. It's another broker machine, another broker machine here, another broker machine, okay. Okay, and this is a cluster. This is a Kafka cluster. Okay, this is what you call a cluster. So let me name it. I don't know if I can write sideways. So this is a Kafka cluster, meaning a collection of machines or servers working together, and they are called brokers. So each of them is responsible for storing event streams, okay, to these topics, okay, that we have talked about. So, but I said once you connect to one, okay, connect to this, okay, if you can connect to this broker, okay, it means you can connect to this other one, okay, you can connect to this one, every other broker, okay, that you want. So you'll hear a term called bootstrap server, meaning it's a server that you can use to connect to any other broker. From any broker, you can connect to every other broker. So we talked about topics up here, okay? And why I brought about brokers after talking about topics is because I wanted to let you know that topics in Kafka, okay, are handled by the brokers, okay? The brokers are the ones responsible, okay, for knowing that, okay, this topic, okay, this event is going to be written to this topic, okay? For example, maybe we have an event, okay? We have an event, okay? An event maybe for payment, okay? Someone has made a payment. We have the key, payment, the value, okay, and the timestamp, okay? So a broker will know that, okay, this payment is supposed to be, this payment event is supposed to be written to the payments topic, okay? That's what brokers are responsible for, okay? And the next thing I want to now talk about is what they call producers, okay? So I'll go to the next right here and talk about producers, okay? What are producers? Let me write this better. What are producers? So these events which are written to Kafka topics are published by something, okay? What publishes them is a producer, okay? So a producer is simply clients, okay? A producer is a client, or producers are clients that write events to Kafka, that write events to Kafka. As simple as that. And in the next stream, you're going to see how we're going to do this. So events that write, clients that write events to Kafka. So this will be like we have a producer, okay? You have a producer P, which will say, okay, we have an event, okay? An event, and the producer will define the event key. It will define the event value. It will define the timestamp. And then this will be handed over to Kafka, okay? And Kafka, okay, will be responsible, given that event, for writing that event to the particular topic, okay? Remember, a topic is simply a logical collection of events, okay, grouped together, okay? So we shall have topics for payments, topics for bookings, topics for tickets, okay? So ideally trying to, and also topics for also notifications. Ideally trying to tell you that we are collecting together events for notifications alone. We are collecting together events for tickets alone. We are collecting together events for payment alone. We are collecting together events for bookings alone. So that's what usually happens, okay, in a Kafka setup. And we are going to need it, okay, to have a robust application. What else do I want to talk about? I want to talk about now consumers, okay? So we talked about brokers, we've talked about events, we've talked about topics, we've talked about producers. Now the next thing we need to talk about is consumers, not producers again, but consumers. Please let me know if you understand this. Let me check the chat after writing this to make sure that everybody has understood and if there's a question. So if you have a question, don't hesitate to ask, okay? Whether you're watching right now or you're going to watch after the stream. So let's talk about Kafka consumers. What are Kafka consumers? Okay, I hope by now you see that these are very simple concepts to understand. Okay, there's nothing really complex. Once you give it time to think, okay, it is very, very simple. Okay, very simple. There's nothing complex. And when you see me writing the code, you're going to see it very simple. There's nothing complex about it. Okay, it's all about you understanding the concept, understand what you want to do. Okay, and you can write the code anyhow you want. You can even tell AI to write it for you. Okay, and do a code review and make sure it is as good as you want. So what are consumers? A consumer is a client. Okay, this time, or clients that read events. Clients that read from Kafka. They read events from Kafka. So you can say the opposite of what a producer is. So consumers, okay, simply as soon as a producer publishes an event, okay, Kafka, okay, gets it, the Kafka broker takes it, okay, stores it, okay, and then all consumers which are listening, okay, consumers which have subscribed, based what it says to subscribe, okay, which have subscribed to a particular topic, okay, will be responsible for reading that event, okay, so that it can be processed, manipulated, and worked with, okay, according to the purpose that the developer wants to do. So let's do another walkthrough. Let's say, for example, we have a producer, okay. You have a producer. What does this producer do? The producer generates an event, okay? Publishes an event. And then Kafka picks up this event, okay? So this would be Kafka picks up this event and knows, okay, this event is probably for payment, okay? A payment has happened and this belongs to the topic, okay? Or maybe payments, okay? So topic of payments, okay? So you have this, so you're assuming you had previously maybe 2 events, okay? So Kafka would add this new event down here. Remember, they are ordered, okay? So it is append only, okay? It is append only. So for it to be consumed, to be read, okay, you must have consumers, okay, or clients which are ready to read, okay, from this topic, okay. So this is the consumer. So this is how the setup is. They're just names, okay? A client which reads, okay. As soon as an event happens, it reads immediately, okay. And one thing you should know about Kafka is that you can have multiple producers and multiple consumers of the same event, okay. Because assume you had this, okay. You had probably several events, okay. You had the topic, okay. You had the topic, okay. So I said you have multiple producers, so I'll use P for producers, okay? So you have a producer P here, a producer P, okay? Another producer P, okay? All producing the same event, okay? That would mean they're actually making use of the same topic, okay? So you have multiple events here, okay? So many events because you have a number of producers, okay? Publishing these events. So what would happen? You would also need a consumer, okay? So I'll say this is topic. This is a topic, okay? Topic maybe of payments, okay? And this particular one is an event, okay? Is an event. And then you have consumer, okay? You have a consumer here. But the only challenge is that this consumer, okay, is not enough, okay? One consumer, because of the so many events, the consumer cannot handle all these multiple events being produced by so many, being published by so many producers. So it would fail, okay? It would maybe get overloaded, okay? So for how to have fault tolerance, what would happen is that you'd have another consumer, okay? Maybe establish another consumer, okay? Maybe 3 more consumers, and maybe using an algorithm like round robin, okay? Whatever mechanism you can set up, they all consume, okay, from this topic. So you can have multiple publishers and multiple producers, not publishers, but multiple producers publishing or creating events to the same topic or several topics. And you can have multiple consumers consuming or reading events, okay, from the same topic or several topics. So you can have a multi-producer, multi-consumer setup, okay, as simple as that. Also, don't forget that these events are ordered, okay? They are ordered, they are immutable, okay? And they are consumed or read in a specific order. Never forget that, okay? Very, very important. Now, one more thing I need to let you know is this, okay? Because I told you that Kafka is a distributed system, okay? And now you're starting to understand how it is distributed, okay? That you have a number of producers, a number of consumers, okay? And also you can have a number of brokers, okay? Remember, you can have many server machines, okay? Working together, okay? To make sure that everything is going on well, okay? But one more thing I want to mention is this. Kafka has another concept, okay? What is called partitions, okay? Partitions. Let me write this in uppercase. Partitions. Again, if you're not understanding this, please let me know in the comment section. There is no dumb question, okay? There are only dumb answers. Let me look at the chat. So if you have a question, don't hesitate to ask, or you can even type it in the comment section if you are watching this after the stream. This is a very, very important topic that can help you build very good applications and separate you from the crowd. So ensure you learn and master it. Okay. So a partition is simply a chunk or a piece of a topic. Okay. So topics are broken into partitions. Assuming we had a topic. Okay. We had a topic which is responsible for payments. Okay. So here we are. Topic payments. Okay. And this topic simply is a collection of events, okay? Logical separation and collection for events concerning payment. So you have a payment event here, payment, 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 paid, payment, okay? Payment, 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 okay? Like that, several of them. So now what happens is that this topic, okay, is now broken up into partitions. Okay, so I can come here and break it up. Okay, say I break it up like this. Okay, so here we have now 3 partitions. Okay, this means this one single topic has now been broken into multiple logs. Okay, and these logs are now can be located on different Kafka brokers. This is what makes it distributed, not centralized, but distributed. You can have a broker handling this. Okay. Remember, a broker is simply a storage. Okay. You have a broker for this one. Okay. You have broker A handling this partition. Okay. You have broker B. Okay. Handling this partition. Okay. Broker B. Like that. Okay. Then another broker handling this. Okay. Let's say broker C. As simple as that. And like I've told you, these are all partitions, okay, on different brokers. So that's what a partition is. Simply a division, okay, or a separation of a topic into separate chunks, okay, and there are now multiple logs on different brokers. Why? Because when you have this kind of setup, okay, the work of storing messages, writing new messages, and processing existing messages can be split among many nodes on the cluster. Okay, what's a node? Simply a machine or a server. Okay, so all the tasks is now shared. Okay, so this one is storing, this one is reading, this one is doing this. Okay, and this distributed placement of the data, okay, is very important for scalability, because now it allows different client applications to both read and write data from many brokers at the same time. This is what makes it distributed and fault tolerant. Okay, so that is what you need to know about Kafka. And maybe one more thing I can talk about is maybe replication briefly, but I think you by now you should in your mind have the idea that replication actually exists. Okay, and it is simply a very important thing that you need to have. Okay, so that the data in your application or in this application is highly available and fault tolerant. Okay, so every topic can be replicated across several regions. Okay, across several geo regions or data centers. Okay, which means that uh, there are always multiple brokers which have a copy of the data. Okay, and a common production setting in Kafka is that you set a replication factor of 3, meaning there will be at least, not at least, but 3 copies. Okay, there will be 3 copies of your data. Okay, for every topic. So let's assume this is maybe this is maybe a partition, okay, of this topic, okay. Then maybe for this topic, okay, maybe you have another copy, okay, in maybe another data center, okay, having the same information here. You have another copy maybe in another maybe geo region, okay. So in case maybe this dies, okay, you have this and this one working. You get. That is how fault tolerance is achieved. So Kafka is really something simple to understand. Then there's something what is called Kafka Connect, okay, which you can use to connect to key value stores, search indexes, okay, Kafka brokers, and so on and so forth. Okay, and yeah, you can read more about them, okay, but not important for this kind of stuff, okay, of this project for now. Even you can connect to things like Hadoop, okay. If you don't know what Hadoop is, there's no problem. It's okay, but think about Hadoop as a technology which helps with big data. Then to handle Kafka streams, like I talked about streams earlier, you can use something called Kafka streams, okay. There's an API in Kafka called Kafka streams, which helps with uh, streaming, okay, real streaming, okay. Of course, you can do simple stream processing using the normal producer and consumer APIs, but for complex transformations, okay, you need the Kafka streams API, okay. And ours is not so complex, so you're going to see me creating partition. I mean, not partition, but creating topics, creating a publisher, creating a consumer, okay, and it will be very, very basic and simple. So to wrap up, in simple terms, okay, you have Kafka, which is an event streaming platform, okay, which helps you achieve fault tolerance, scalability, and it will help us with event-driven architecture for our case in the flight booking engine. And we are going to publish events, okay? An event will have a key, it will have a value and a timestamp when it had just happened. And after that, this event, okay, will be tied to all other events which are similar to it, what is called a topic. So we shall create topics, okay? We shall publish events to topics. So we're going to create publishers, we're going to create producers, okay, which will be responsible for publishing events. For example, we shall have a publisher for events, maybe when someone creates a booking, okay, when someone maybe makes a payment, or when someone maybe uploads a ticket, okay. So an event will be published, and then after that, we shall be able to consume them. We shall have a consumer, okay, which knows that, okay, right now, if a booking has been confirmed, let us now send number one, an email, okay, or let us send, for example, maybe a notification, something like that, okay. Or right now, a ticket has been, so if for example, like an admin uploads a ticket, we publish an event saying ticket has been uploaded, okay? And then a consumer will read that event and then send an email, okay? That way, we are solving a major problem which the application had, okay? Which is that when you upload a ticket, okay, then in the same FastAPI process, we were sending an email, then sending an in-app notification, okay? So this task of sending an email, we can remove it from the FastAPI process, okay, and leave it to Kafka, okay. It will give us a faster way of processing things, okay, because in the event that we have so many, okay, requests coming up, okay, events will be fired, okay. So immediately, for example, like immediately an admin uploads a ticket, okay, we simply return success to the user, okay, and fire an event saying that a ticket has been uploaded, okay. We don't immediately send an email, okay, because SMTP has its issues. Even when we are using a FastAPI background tasks, okay, that dependency actually has its issues, okay. It is still using the same FastAPI process, okay, which is bad. Which means if the server restarts, okay, imagine this: if a server restarts when an email is being sent, we have lost it. Okay, that's the problem. But with Kafka, we shall have that event stored, okay, and we can get it in real time or even later. Okay, that's the good thing. Our data will be stored, and of course, if you want to expire your data after some time, you can do that. Okay, but I hope you've understood what Kafka does. Okay, again, there is a lot to Kafka that cannot be covered in a single stream like now. Okay, but you can go ahead and read this page. I'll leave a link in the link in the description. Read it and get to understand what Kafka does. Okay, this is something you can read in 10 minutes, okay, or less. And after that, in the next video, we're now going to implement an event-driven architecture. We shall install Kafka. We shall install Kafka in our compose file, okay? After setting up Kafka in our compose file, we shall make sure that in that compose file, our FastAPI app depends on it. Then after that, we shall go ahead to install a library in Python, which will help us to connect to Kafka, okay, running in as a container in Docker. After that, we shall then define a producer, okay, of events, okay, and after that, we shall also define a consumer of events for our flight booking engine. But I wanted us to, first of all, understand this at a basic level. Then later, not basic, but in fact, I think I've gone beyond basic in this stream, but understand what Kafka is all about is. And then we now go on to building and seeing what Kafka is, okay, and how it will help us. So yeah, this is us almost coming to the end of the flight booking engine. And many of you have been asking me, when are we concluding? When shall we wrap up? Okay. I want to say it's not about maybe wrapping up, but learning, okay, and understanding as much as we need. So yeah, I hope that within the next maybe 10 to 15 streams, okay, I am done with the MVP, okay, and maybe other features will be things which I can do privately on my own, okay, on the side. But I wanted the MVP at least to have all concepts that you guys can be aware of, okay, and you can go ahead to learn 5 times more than what I've showed you, okay. Like concerning backend, learn 5 times more than I've showed you. Frontend, learn 5 times more than I've shown you. DevOps, learn 5 times more than I've showed you, okay. Everything. For example, if you've talked about Terraform, go deeper into Terraform beyond what I've showed you. If concerning like Kubernetes, go deeper. Concerning Kafka, go deeper, okay. Concerning Redis, go again deeper, 5 times deeper. Concerning the front end, go deeper. Concerning server set events, go deeper. Concerning AWS, go deeper, okay. There you'll be good and really good enough, okay. So yeah, it's time now to wrap up the MVP, okay. So in the next stream, let us now implement, okay, Kafka in our application and have it working. Again, thank you for watching with me, and I hope you are learning something. If this has been valuable to you, like this video, subscribe, share it with people in your network whom you think can benefit from this playlist. Enjoy and have a good holiday.